In today's webinar, the main question is, have we achieved the industrial grid parity? In the industrial grid parity, you can see here on the left side a graph some years ago where we drawn the industrial grid parity price, so the electricity price for industrial consumers. For sure, this is also depending on the size. Here then on the graphs we showed here the levelized cost of electricity energy for two different locations, so one in Italy in Bari and other one in Munich, and we can also see here the break-even points. On the other side, you see there an overview about the electricity prices in Europe, which we took as base for today's section, so that we can really discuss, do we really achieved it, where do we stand within Europe. First of all, I want to explain what is LC, what is impacting LC. Then I go to the local system prices and LC. Then I show you the system optimization depending on the location. And finally a summary, what is answering, are we there yet? Did we achieve the industrial grid parity, or what is the status in different countries? First of all, what is LCE? LCE is the sum of the cost during all lifetime, the capex cost, operation maintenance cost. So you can see here a breakdown. We have here the system cost, what are the capex, what is split into the fixed BRS cost, the variable BRS cost, for example, substructure cabling, then the module. Then we have the financing, especially for larger and utility scale projects. So on the residential sector, it's usually not always interesting. And then for sure the operation maintenance costs. For example, how often do you have to exchange an inverter? How often do you have to exchange modules? How often have you go to site and clean? And the DEF is standing here for development costs. So here in the graph, what is from first order, they also include a section for development costs, what is covering the project development. Then the second important point is the energy produced during the lifetime. Here in the graph you can see an example from one of our sites in Italy, in South Italy, where you can see that the power plant is running quite good and that we overachieved the expectations, which means that the quality level of all installed components is on a very good level and the system is running fine. These are the important points to achieve low levelized cost of energy. What is also impacting? If we go now with a more detailed look or a little bit more deep on the breakdown, here's the green part. Here the green part, you can see the capex, the system. The system is depending on the module you select, the inverter for sure, the substructure, the design. So if you go south, east, west tract, or if you want to go on a facade, for example, then combiner boxes and stuff like this. Then the system design is for sure directly impacting here the green marked area, but it has also a direct and indirect impact on the financing with the bankability, for example, for modules or for inverters or the complete system. But it's also impacting indirect if you can reduce your capex, then it's also directly impacting your financing. And for sure the operation maintenance costs. Operation maintenance cost is also impacted indirect by the system. So how easy you can clean, how easy you can make maintenance, and also about the components you select to have a high quality power plant and to have low operation maintenance cost during the lifetime. For example, here you can see the impact if you are having good component or good quality components, if you achieve the energy yield you expected, or if you have a low degradation or high degradation. And for sure, if you have good quality components, then you can reduce it further. Or if you make the experience after several years that the component quality is not at the level you expect, then the LC can also go up in the negative direction, which is reducing your profit. Now we go to the local system prices and LC. First of all, the graph on the left side you already know from before. That are the variable costs, and on the right side we have here the cost of electricity and the LC, how is it expected to develop within Europe and Southern Europe, and you can see that currently in 2015, as you also may know from Germany or from tendering, that even there the LC for in tenders is below 8 cents, and it's also expected that that there's a further drop of 30% within the next 10 years, and by 2015 it will be expected to be in Europe between about, let's say, 2 to 4 cents. Even with the lower irradiation what we have here compared to the MENA region, as you may know, in the MENA region some of the tenders already showed that they are going in the direction of 2.5, 3 cents. Here's a short overview about system prices. So I marked here France and Sweden because we are discussing today France and Sweden beside Ireland and Turkey. I took these countries as example for today to show you how they behave, what are their differences, and what is the status. And you can see that for France, we have system prices for utility scale between 90 cents and €1.30, and in Sweden it's between 1.2 to 1.4 euros per watt peak. Now we go to the system optimization depending on the location. As said before, today we will speak about different locations to give you an overview about Europe. So I selected Stockholm as a very north location, then Esrin in Ireland, then Toulouse in France, and Zanlurfa in Turkey as a location with the highest irradiation. Based on the graph I have shown in the beginning, I took out the industrial electricity prices. The electricity prices displayed by the OECD is between, in Stockholm the lowest with 80 euros per megawatt hour and the highest in Ireland with 145 euros per megawatt hour. For sure this is clearly depending on in which kind of branch you're within the industry and what kind of electricity price you get really offered. For sure this is depending on your size of the business and can be also lower than shown or higher than shown. But we will take this as example to see where we are. First of all, the most important point is the irradiation. Here it's shown the energy what is injected into the grid based on the irradiation what we have in plane. Here I took different locations. So for Ireland you can see that there's a certain difference between south, what is always displayed in blue, and an east-west system what is displayed in orange. You can see that the highest difference between summer and winter is for sure in Sweden, but it's also quite interesting to see that based on the climate information what I got from Zoologist, for example, or what I get from Meteonorm, that the weather in Ireland, especially in Essenry, is much more unstable, even more unstable than in Stockholm. This leads also that the total irradiation and the total energy yield you can have in Ireland is even a little bit below the level in Stockholm. And for example, if you look on Turkey, you can see that although during winter times you have a quite good performance with a south-orientated system, and with an east-west you have a certain drop in the winter season. Also in France, in Toulouse, the level is compared to Stockholm higher. That means also during the winter months you're producing much more energy than, for example, in Stockholm. This information can be used, for example, also to align with your project. So if you want to achieve a high number of direct consumption, then you can use the information to design your system, decide if it makes sense to go for south, where you have a lower capacity per hectare or per square meter roof, or if you go for an east-west with and accept some energy losses, especially during the winter months, but having a higher capacity on the roof to bring the best out of your project. If you now take a look on the energy density, the energy density is shown here for the different locations. You can see that the global behavior is quite equal for the different locations. But you can also see that, for example, here in Turkey, depending on what kind of module orientation you select, it can also make sense to go with a different orientation to have the same energy density. For example, in Ireland, with the south system, you cannot achieve the same, but in Turkey, especially in the south of Turkey, if you're around 22 degrees, you can see that the energy density from an east-west orientated system to a south-orientated system is equally. This is based on the lowest sun angle. Here in this analysis, I selected the lowest sun height for winter, so I selected the point that during midwinter the system is not shaded during noon. If you now calculate the system price and then based on the energy yield, what is for sure different per orientation, then we get a graph out, and there we can see about system price development and the LC, what can be achieved. I took here several ones, though I have here 3 steps for south orientated, then the same 3 steps for an east-west, and finally a facade system. The facade system is mounted to the east, to the east facade, south facade and west facade. For sure, the energy yield, especially for the 90 degrees east-west, and the facade is quite low, which leads also to a high levelized cost of energy. But you can also see that with the facade system, you may be better than with a pure east-west system, especially if you only mount modules on the west and east side. If you want to have the lowest LCE, in this case, the best option would be around 30 degrees in Ireland. But you see that also the difference to an east-west system with 10 degrees is not so big. So if you have a commercial roof, a flat roof, and the consumer inside want to have the highest capacity because he wants to direct consume, then you can clearly think about to install it east-west. Then you know, okay, from the energy yield, from the pure cost, it's higher, but you can have a higher cut from the energy bill. If you also, for example, check or compare the behavior between Ireland and Turkey, you can see that especially the drops or the LC behavior is from the curve quite similar, but the drops are different. So for example, the drop from let's say south facade 90 degrees is much higher in Turkey, though the increase of LC, than here in Ireland or in Sweden. And even if I compare here Turkey with France, with Toulouse, you also can see that in Toulouse the drop or the increase isn't as big as in Turkey. It's also the difference between the south-orientated and an east-west system. And here from the total level, here for Ireland, from the LCE, we are between 15 and approx 27 cents per kilowatt hour. And in Turkey, which is the location with the highest irradiation, we are between around 5 and maximum 10 cents. This is resulting due to the fairly higher irradiation what we have in Turkey compared to Ireland, which seems to have a quite cloudy weather. Now, to give you a short summary, what does it mean? What could we achieve? If you now go back to the electricity price chart, you see here in Ireland, the OECD expects a price with 173. Then for Sweden, it's 90 or 80. Then we have France with 126 and Turkey with 146 per megawatt hour. If you now go back to our map and take 2 systems out. So I took here out a 30 degree south orientated system and an east-west system with 10 degrees module angle. Then you can see that from the levelized cost of energy, if we go here to Essenry in Ireland, the electricity cost from the grid for industrial consumers is given with 100 or with 0.115 euros per kilowatt hour, and the L3 calculation shows that the energy can be produced lower with your own system than if you consume it from the grid. So with a south-orientated system we are below, and with east-west is equal. So depending on the electricity price development, if you want to have the highest capacity, you can go with east-west and can have a stable electricity price for the next years. If you're going to Stockholm with a fairly low electricity price from the grid, you see that we are still above the cost for industrial consumers with approximately 11 cents and approximately 13 cents. But if you go now to Turkey, which have an electricity cost of 13 cents per kilowatt hour, we achieve LCU between 5 and 5.7 cents per kilowatt hour. You see that in Turkey it's very interesting to build or to use PV for industrial applications as well, for let's say also commercial buildings, because you can produce the energy much lower than what you pay if you consume it from the grid. That means even if you can only reduce your energy bill because you cannot produce as much as you consume. For example, if you have, if you're in the steel casting, then you have a very high energy consumption, but you can cut off a part, for sure, depending on what you have to pay to the IPP. If you now take as finally a look on Toulouse, there we have electricity costs of around 11 cents. And if you check what the costs are, if you produce electricity by an PV system, then we are between 8 and 9 cents depending on the orientation. This shows that in a big part of Europe, for sure, depending on what is the electricity cost in the country, what can vary, and can also vary from the season, from the year, and the overcapacity on the market. But you can see that based on the price given, that in some parts of Europe we are already on a level that we achieved the industrial electricity price, so we have industrial grid parity. That leads to the statement that we can say, yes, with the PV you can produce your own electricity cheaper than what you consume from your grid. Finally, I want to show you another graph for the United Kingdom. And although this shows that depending on what is your self-consumption and the price and the price development, you can see that it's also expected that it makes sense to use PV, especially in the long term, to be anyhow much more attractive from consuming the electricity from the grid. So I want to take the opportunity and say thank you. I will now check for questions. If you have questions, then please put it in the question section, and I will go through and answering all your questions. So there's one question about do you have an assessment on the true competitiveness? The electricity price comparison includes the taxes and leaves on the electricity price. This is slightly biased, as we should probably start comparing our cost more to the real market value of electricity. For this question, it's hard to answer because it's really hard to get this kind of information. As you could see from the prior slide, they tried to include it, but it always depends on what is the purpose of the system. If you have a system what is placed on a field like a utility scale, then you might be more affected than if you have the system on your own roof and if you make a direct consumption. Can we download the presentation? Yes. So the presentation and the recording will be shared afterwards. Data for Greece. This can be discussed, I would say, afterwards. So if you want to discuss it, then please write me an email. My email address is stefan.ringbeck@trinasolar.com. Because in this analysis, I only took out 4 locations, but for sure we can discuss as your case. The question is, why is it the financing with 33% so high? So it's for sure biased by the interest of the banks. What we should not forget, I mean, this is an example from First Law from the United States, and is also impacted from the, let's say, behavior inside the US. But it should also show that financing on the complete cost is an important role, and makes the needs of that you have a system with bankable components and a good system designed to ensure that the payback is given and the system is running good. The question, if I have a map for grid parity in Europe. For grid parity, there we have to first to check for the several levels. So there's grid parity, for example, for residential, for home users, and then for the different kind of industrial cost, because this is quite a range, and then the utility. So I would like to have a map, though I tried to make my own map because these numbers are not so public available, especially if you're talking about industrial grid. So you find more about residential grid parity. There's the question, why is self-consumption not working in Europe? That's a good question. I would say it depends on how it's communicated, and depending on how the message gets transferred to the owner. Though the people who are, let's say, impacted by the self-consumption. Basically, I would say it should be successful, but it also depends on how we can transfer the message, and that's also the secret, because we also had a topic about self-consumption, and even here you can see that self-consumption, direct consumption makes sense, and but there we need to think about how we can really transfer the message. So it depends on the people transferring the message to the business owner. Do we have information about Spain? Also for Spain we can calculate and compare with Turkey, that's possible, but this we can do only after the webinar. What's about storage in the system? Storage is here in this case not part of this presentation, because it should show the pure costs. But yes, storage can be included in the system. In the case I took, it's not included. Though if you want to consume the energy, it's more like direct consume, and the overcapacity then you have to sell to the grid, and then you have to make deals with the grid owner or with the IPP how much you will get for every kilowatt hour, especially if there is no feed-in tariff. The question is, what was the price of the system in euro per watt peak I used in my calculations? Let me go back. Here in this graph we have the system prices and the system prices for the different locations. So I adapted slightly to what I've seen in reports and what is, let's say, the assumed cost for labors. And the system prices are between, the lowest one are for sure in Turkey, around 90 cents up to 96 cents, and for Ireland, what was the most expensive one, between €1.19 to €1.26. that are the assumed system prices. They are not the most aggressive one we have seen, especially if you compare to utility scale project. Though if you can achieve, or if you have more aggressive prices and lower prices, for sure the LCU will drop further. There's a question if you have an analysis for Iberic Peninsula. I would say for this it would be great if you can drop me an email and then we can discuss it afterwards. So then we can provide you some information or what we expect as L3. There's a question if we think in the next years in Italy there will be the condition to energy to be sold in the grid. I would say it depends a little bit. I mean, there we have also to think about what the government, the politicians are doing. But from the prices and from the prices you can achieve with PV, especially in the south part of Italy, this can be directly sold into the grid because it should be on a similar levels than some conventional power sources. There's a question about the financing assumption. So my assumption is that for sure part of the system is financed and there's a certain interest rate in, though the interest rate is 5%, and the debt is 80% of the total cost, and the payback time is approximately 10 years. From the module prices, their average price in, though it's not let's say not very strong biased by the different prices by the different locations, though there I took an average price for Europe for the modules. The source of the capex prices, they are given in the link what is below the picture. There's a question, can I explain payback? So payback is basically the time you need to pay back the debt or to pay off the complete system. The grid costs are not considered here. There's a question is how did you take grid costs in the system price for France? So for the LCOE there are no grid costs in, so it would be more you have the PV system on your roof and then you consume it in your office space or in your machine hall. So if you have to transfer it via grid, like for example we also have here in Switzerland that we have the pure electricity cost and then you have an as add-on cost grid costs. This needs to be added, especially if you have transferred via the grid, because your plant is not located on, let's say, on your side. It's taken from a utility scale. Why are the capex so different depending on the country? One of the biggest impact are the labor costs, especially if you compare Turkey and Sweden. There's a very big difference in terms of labor cost. There's a cost per hour you have to install the system, and for sure it's also part of where you can source the components. And what we also have seen is certain different in terms of margin between the countries. So for example, if you take a look to US and if you see there the prices for residential system, they are still extremely high compared, for example, what you get in Europe or in Germany. So in US it's more like $3 per watt for a residential system, what I've seen in the latest reports, and in Europe it's basically around 1.5 or even below. Okay, I see that's all. For the open questions, or if you have further questions, let's say, then it would be great if you can drop me an email. Those that I can answer all, and I want to say thank you very much for your attendance. And if you have questions, please drop, and for sure we will place the recording and send you the presentation after the webinar. Thank you very much. Have a nice day.